Hello everyone. Today our topic is eigenvalue and eigenvector. So let's see what it is. So what is eigenvector actually? Eigenvector is something where if we multiply a matrix A with a vector x bar, then we get the same vector multiplied with a scalar value. So if we see the formula here, A times of x bar equal to lambda times of x bar, where A is the where A is any matrix, x bar is the eigenvector, and lambda is any scalar value or the any scalar value or known as eigenvalue. So this is the formula for finding the eigenvector or the eigenvalue. Okay, so in exams we get two types of problem, where first is the to verify if the given vector is an eigenvector or not. Okay, so let us see an example where A equal to the given matrix equals to -3 1 2 0 and the eigenvector given is 1 1. So the first question is verify if x bar is an eigenvector. Okay, so how we will do, we know this formula, right? So we will do A into x bar. So let us multiply this to A into x bar equal to -3 1 2 0 multiply with x bar 1 1. So we get this as, we will do the row and column operations here. So this multiply by this, -3 into 1 plus this multiply by this plus this multiply by this, 1 into 1. So this is the first row. Then this multiply by this, so we will get 2 multiply by 1 plus 0 multiply by 1. So the resultant vector comes as -3 plus 1 is -2, and this comes as 2. Hence we can take 2 common from here, which we get as -1 and 1. Hence -1 and 1. Hence this is not equal to the x bar. So we say like A into x bar is not equal to lambda times of x bar. Therefore x is not an eigenvector here, and we cannot find the eigenvalue also. Yeah. Okay, so after this we have second type of problem. If you want to note it down, or else I can start. So second type of problem we get is solve for eigenvector and the eigenvalue. So we have got the matrix, and then we need to find out the eigenvalue, the lambda value, and the eigenvector x bar. So let's see how to do that. We have got the matrix A equal to 1 1 4 and 1, and we need to find lambda and x bar. Okay, so this is the second type of problem that we get in our exams. Okay, so we know this formula. So for all non-trivial solutions of x, we can write this equation as equal to lambda times of x bar. So we can do it as A minus lambda times of identity matrix multiplied with the x bar equal to 0. So for all non-trivial solutions of x, we can write it as A minus lambda equal to 0, or determinant of A minus lambda I equal to 0. So to find the lambda, we can do this equation. Okay, so we will be doing like 1 1 4 1 minus lambda times of identity matrix. So what is an identity matrix? We have all the elements except the diagonal elements as 0, and in diagonal we have ones. So like this, okay, equal to 0. This should be equal to 0 as determinant of, no, not this, like determinant of this should be 0. So we will solve this. 1 minus lambda 1 4 minus lambda. This is the matrix that we got after solving this. Okay, so the determinant of this will be the cross multiplication of this 1 minus lambda into 1 minus lambda, and then minus 4 into 1, so it becomes 4. So this is the determinant of this matrix, so this should be equal to 0. So for lambda, if we solve the equation, we will get 1 minus lambda minus lambda 1 minus lambda minus lambda plus lambda square minus 4 equal to 0. Okay, so if we solve this, lambda square minus 2 lambda minus 3 equal to 0. Okay, this is a quadratic equation here we got. So if we solve this, what we will get? Lambda square minus 2 lambda minus lambda minus 2 lambda minus 3 lambda plus lambda minus 3 equal to 0. So if we take lambda common, lambda minus 3 plus lambda minus 3, or lambda plus 1 into lambda minus 3 equal to 0. Hence we got the lambda values here, minus 1 and 3. Lambda equal to minus 1 and 3. So we got the values of lambda here. Okay, so the eigenvalues for this for this matrix is minus 1 and 3. Okay, lambda equal to minus 1 and 3, that we are going to write here. So if we substitute the value of lambda here and find the write the equation again, A times of 1141 times of x bar x1 x2 equal to, assuming lambda as minus 1 times of x1 x2, so it will become x1 if we multiply this, like, okay, x1 plus x2 equal to x1 plus x2, and if we multiply this, 4x1 plus x2, minus x1 minus x2. Okay, so if we solve these equations, it will become so if we solve these equations, it will become So this one, so if we take this here, we will have minus this equal to 0. So we get the equation as 2x1 plus x2 equal to 0. And 4x1 plus x1 5x1 plus 2x2 5x1 plus 2x2 equal to 0. So for now assume x1 equal to 1. So when assume x1 equal to 1, then we get the x2 value as minus 2 for this equation. Okay, then we get the x1 and x2 as x1 is 1 c and minus 2c, x1 and x2, so c and minus 2c we can say, right, x bar. So this is for lambda equal to minus 1. Now we will do for lambda equal to minus for lambda equal to 3. Okay, so let us do this. 1 1 4 1 x1 x2 equal to lambda 3 times of x1 x2. So we will solve this equation. We will get x1 plus x2 and 4 1 x1 plus x2 minus 3x1 3x2 equal to 0. As we know, a minus lambda equal to 0. A minus lambda I into x equal to 0. So we will do this as x1 plus x2 minus 3x1. So what it will become? Minus 3 plus 1 minus 2x1 plus x2 equal to 0. And the second equation will be 4x1 minus 3x1. x1 plus x2 minus 3x2 minus 2x2 equal to 0. Therefore x1 equals to 2x2. So when x1 is, assume x1 equal to 1, assume x1 equal to 1, then we get x2 equal to 1 by 2 times of equal to 1 by 2. This is number 1, this is number 2. Therefore the x bar will become, substituting values of this, c of 1 comma 2, c of 1 okay. Therefore we got the eigenvector as any constant multiplied with a 1 2. So this is my vector, final vector. So thanks for watching me.